Alright, in this lesson we will continue our work studying circles and specifically talking about the relationships between different kinds of angles and arcs. This is the second lesson practicing working with mostly inscribed angles and central angles and how they compare with arcs. So you should probably watch the day 5 lesson if you haven't already watched it. The two main relationships that we're dealing with. This is a central angle, looking at the angle theta right here, because its vertex is at the center. So when I talk about the central angle, I'm talking about this angle right here. That is a central angle. When you have a central angle and you want to talk about the degrees, the angle measure and the arc measure are the same. So if this is a 30-degree angle, then this is a 30-degree arc. On the other hand, when you have an angle that goes all the way to the edge of the circle, that is called an inscribed angle. And the relationship is the angle is half the size of the arc. So if this is 30 degrees, the angle, that means the arc must have been 60 degrees. So you can either look at it as the angle is half the size of the arc, or the arc is double the size of the angle when it is inscribed, meaning the vertex is on the very edge of the circle. So in the day 5 lesson, we did all the odds, and today we're going to do all the evens. So with that in mind, let's look at problem number 2. Okay, we are supposed to find the measure of arc ST, okay, which means we are looking for this. This is arc ST right here, like this. Alright, fine, that's what we are being asked to find, the red. Now, in the meantime, we are given this angle that is 61 degrees. That is an inscribed angle. If that is 61 degrees, then this arc that I'm showing here in green should be double that. Okay, so that's going to be 122. So this green arc is going to be 122 degrees. Okay, that's double. But hopefully you can see that we are working overall here with a semicircle. We've got a semicircle going from here all the way around to here. Okay, that orange there is a semicircle. And of course the semicircle is 180 degrees. So if the green part is 122 degrees, we should be able to just subtract 180 minus 122, and that should leave me the red. So the measure of arc ST is 58 degrees. I'll just go ahead and put it up here as well. 58 degrees. Alright, moving on to number 4. Okay, this is a central angle. So just keep that in mind. We're supposed to find the measure of angle JLM. J to the L to the M. So this is the angle that we're supposed to find. Let me see if I can do it neatly using the properties of Microsoft Word. Okay, yes, so let me darken that in. So that is what we are supposed to find, that red angle right there. That's our goal. There's a couple different ways to do it, but here's the one that occurs to me first. I'm always on the lookout for a diameter. So you know what, I sort of think backwards, I guess. If I know if I want to find this angle right here, well, I'll just put a question mark for a second. I know that if I had this arc, I just feel like I should change colors for a second. I'll use fuchsia. I know if I had this arc right here, then I would be able to know the angle, because the angle would be half the arc. So I switch my brain and I think, okay, fine, what's this arc? How could I find it? Well, then I think, well, okay, this is a semicircle over here. Wow, that's big. From K all the way around to M, that's a semicircle. So if I knew this part, then I could subtract from 180. It's quite the puzzle, isn't it? But bottom line is we do know that part over there because of the 88. Okay, this arc must be 88 degrees. So that's 88 degrees, all right, because the angle, it's a central angle, so it should be the same. So if that's 88 degrees, I can find the other half of the the other part of the semicircle by subtracting from 180. So I should be able to find this guy by doing 180 minus 88. Okay, so I think that's going to be 90. Okay, so if this arc is 92 degrees, the pink arc, then again, now I should be able to find the angle by taking half of that. So that is going to be 46 degrees. And that is what we were supposed to find. So angle JLM is 46 degrees. So these are like little puzzles, but I think a strategy of working backwards will sort of help you. Again, first I looked at what I'm supposed to find, then I followed that backwards. I knew if I could find this angle by knowing this arc, and I could find this arc by looking at it as part of a semicircle. Okay, let's find number 6. Alright, we are supposed to find the measure of angle K. Now look, on a previous episode, we learned that if you have this sort of a bow tie, hourglass type situation with the double triangle thing happening, all vertices on the circle, it was going to turn out that these angles that are on the same side together are congruent. So, for example, angle K and angle L are going to be congruent, and angle J, I'll double mark it to show the difference. Okay, angle J and angle M are going to be congruent. Okay, and that makes sense. Let me just say this really quickly. Looking at angle K and angle L, for example, the reason why we knew they were the same is because they both reach out to the same arc. All right, for example, say if we knew that this arc was 40 degrees, let's just say, for example, it was. Well, then what would that make angle K, which reaches out to it? Okay, if that's 40 degrees, then wouldn't angle K be 20? All right, it's got to be half. But then, on the other hand, look at angle L. Angle L is in the exact same situation, all right, using the exact same arc. So half of 40 again, angle L would be 20. So if this arc were 40, guess what? Angle K would be 20, and angle L would also be 20. Obviously, we don't know what angle, what arc JM is. Actually, we do. We do, because we know that this angle is actually 28. So we can be really actually precise about this. So if we know that this angle is 28, we should be able to double that, and that's going to be 56. And but if this arc is 56, then you take half of that, and that's going to give you angle K, which is going to be 28 again. So that's sort of the long way. Once you see it once that, oh, double it, you get the arc, half it, you'll get the angle, you can sort of skip a step and just know that these angles will be the same. And really that's it's good to understand where it came from, but I want you to get comfortable with the two angles on the same side will be the same. So K and L will be the same, and if it comes up, J and M would also be the same. Anyways, angle K was 28 degrees. Moving on. Looking at, let's find number 8. Oh, okay. So this one is going to start to use this picture over here. So I might have to zoom out. Okay, find the measure of the indicated arc or angle given that arc LM is 84 degrees. Okay, let me mark some of this stuff in purple, blue. I think I will use blue. Okay, arc LM is 84 degrees. So let's mark that. Okay, so we know that this, we're given that this right here is 84 degrees. And we're also given that arc KN is 116 degrees. Okay, KN, which I will show in purple. All right, from K all the way around to N is 116 degrees. See how I'm using these colors? I highly recommend that you use colors too. So obviously you're using paper and pencil, but you should use markers, colored pencils, highlighters. It really makes a difference to be able to do what I'm doing and color these parts in color. So I highly recommend that. Anyway, now that we've marked the given, let's look at what we're supposed to find. So for number 8, we're supposed to find the measure of angle JKL. Okay, I like to mark what I'm trying to find in red. So angle JKL, we are trying to find this angle right here. J to K to L. Well, that's a given, okay? See how this across here is a diameter. Okay, this is a diameter of the circle. That means we're looking at a semicircle. I'll just briefly mark this in yellow. This is a semicircle going from here around to here. It's a diameter semicircle. So since this yellow down here is, I know this will be hard to see, but since this is 180 degrees, automatically this inscribed angle will be half of that. So this angle up here in red at K will be 90. So we know the answer already. Whoops. We know this is 90 degrees. So that's the answer. It's just half of that semicircle. So that's going to be 90 degrees. Okay, let me clean that up. All right, now we're supposed to find angle KMN. KMN. Okay, well, angle KMN is like this, from K to M to N. Okay, there's angle KMN. Well, see how helpful the color is? Hopefully you can see that this red angle KMN has the purple angle as its intercepted arc. You see the two ends of the angle. Well, I mean, it doesn't really end, but you know what I mean. This angle is reaching out and intersecting right at the edges of the purple. So again, this is an inscribed angle, so it should be half of this arc. That's 58 degrees. So that is 58 degrees. Looking at number 12, KLN. Oh, this is just too good. Hopefully you can see this is the exact same situation. This red this red angle once again has the purple arc as its intercepted arc. So this inscribed angle will be half once again, and it will be 58 degrees. Easy peasy lemon squeezy. So let's see, now we're supposed to find arc MJ. Okay, now arc MJ I've shown here in red. Okay, from M to J, that's what we are supposed to find. And again, I direct your attention to the semicircle, my friends. Because for some reason I like to do this in yellow. Semicircle, I'll use orange. Close enough. Here is the diameter on which I am focusing. But looking at the diameter, then I've got this semicircle that's doing this. Okay, so I've got the semicircle effect happening. So looking at this blue, just ignore the purple, it's really not having anything to do with it. Ignore the 116. The 84 is one part of this semicircle, and the red that we're supposed to find is the other part of the semicircle. So of course, all I really need to do is to subtract from 180. So all I'm really going to do is 180 minus 84. So I'm feeling a 96 coming on. 96 degrees. That's what this should be. So really, it's all about the colored markings and everything, because the key to solving these problems is to ignore all the stuff that doesn't matter. All these extra lines all over the place like a spider web, and this extra number over here that we didn't need. If you just focus on the semicircle, it becomes quite obvious. Shoot, 96 degrees. Alright, well that's it for this picture. Again, I did these problems in the previous lesson. You can find the day 5 lesson from the same playlist. Anyway, moving on, let's find number 16. Let's wrap this up. Okay, number 16. In the day 5 lesson, we learned that when you have a quadrilateral inscribed in a circle, that's what this is. When I say inscribed, I mean that see how all the vertices of the quadrilateral are on the circle? That's what I mean by inscribed. But what we learned was the opposite angles will be supplementary, meaning the opposite angles should add up to 180. So I'm going to make this a little smaller so they will fit. So for example, looking at these opposite angles, like the 5x and the 110, these two opposite angles should be supplementary. That means that 5x plus 110 should equal 180. So if I subtract 110 from both sides, that means 5x should equal 70. Then if I divide both sides by 5, so that means that x should equal 14. Okay, so fine, x is 14. Now let's find y. But same story, but this time we'll be using these two angles because they are opposite angles. So that means that 2y plus 104 should equal 180. A common mistake is kids, students, I should say, often feel like everything's going to be congruent. So they'll just set 5x equal to 110, and they'll set 2y equal to 104. But that is not the relationship. They are supplementary. Okay, so minus 104 from both sides. So that means 2y should equal 76. divide by 2 on both sides, and you get y equals 38. All right, so that is how you do problems like this one. Number 18, I'm sure is going to be the same thing. Looking at the x's, these two are going to be supplementary. So I really could just subtract the bottom lines. I'm going to subtract from 180 to find this. But I could go ahead and do the equation, you know, like x plus 108 is equal to 180. Just takes one little extra step. Either way, we're going to wind up subtracting 108 from both sides. Okay, so that's just going to give me that x is going to equal to 72. Okay, so that's x. Now for y, these two angles are the same. So they add up to 180 and they're the same. So the only way that's going to happen is if they're both 90. Okay, so if these are congruent, it has to be 90 plus 90 to equal 180. So y is 90. That was pretty simple. Okay, perpendicular. Could put a little box in here if I wanted to. Hey, that was not a very good box. Anyway, we're almost done with this lesson. Let's find number 20. 2 more problems left. So look at number 20. All right, so we're combining all of this information we've been talking about. So we need to find this angle. We need to find x. So here's my thought process. I'm basically looking for this angle down here. Oh, you know, there's so many ways to do it. All right, I think I'm going to show you 2 different ways to do this, just to make a point. One way to do it is to basically do what we were just talking about a second ago. These are opposite angles. So this angle and this angle will be supplementary. So if I knew this angle A up here, then I could do what I just did on the last problem and, you know, subtract from 180. So one strategy would be to find this angle first and then use it to find this angle. And I could find this angle pretty easily because this angle is right here, and the arc that goes with it is this arc right here, this that I'm showing now in green. But guess what? I know what that green arc is. That green arc is just 152 plus 80. You know, they kind of meet right here, but these 2 arcs together are the green arc. So if I add those up, the green arc, this whole thing is 232 degrees. So this red angle, an inscribed angle, should be half of the arc as we've seen. So if I take half of it, that's going to give me 116 degrees. Okay, that came from doing this divided by 2. And now, finally, I can find the x. I can find the angle x over here. And I can do that by doing just like we did before. I need to make this a little smaller, though. I can, these 2 angles are supplementary. So that means 4x plus 116 should equal 180 degrees. So that's minus 116. Like that, so that means 4x is equal to 64, and then of course we'll have to divide both sides by 4, and that's going to give me that x equals 16. Okay, so that's going to give me x equals 16. That's one way to do it. All right, here's another way to do it. Basically, we're supposed to find, we're trying to find this angle right here. Now, to the arc that goes with this angle is this arc right here, arc DB. All right, this is the intercepted arc for the angle that we're looking for. So if I knew what this arc was, then I could just divide that by 2 and set that equal to 4x. So, but I can find this arc pretty easily. This green arc is made up of 84 plus whatever this AB is. But if you look carefully, 84, 80, 152, we have every arc on this entire picture except for AB. So I should be able to subtract from 360. If I subtract these three numbers from 360, that should leave AB. So AB here turns out to be 44 degrees. That means the green arc, I should be able to add 44 degrees and 84 degrees, and that's going to give me 128. So this green arc is 128 degrees. So if I take half that, that should give me this red angle. So that's going to be 64. So this red angle here is 64. So 64 should equal 4x, since that's the expression that we're given. So another way to do this would be to go, okay, well 4x must equal 64. Dividing by 4, again, x equals 16. All right, so a lot of these problems, there's more than one way to do it. So let's go ahead and find angle y. All right, I'm just going to clean this up a little bit. Okay, I don't need all of this. I don't need this anymore. All right, this is the angle that we're trying to find now, where the 7y is. And you see that this is the arc that goes with it. Again, I'm going to show that arc in green. Okay, now this green arc is just, they sort of meet here, is just the 44 plus the 152. That is 196 degrees. So the green arc is 196 degrees. So if I take half of that, that should give me this red angle. Okay, so if we take half of that, we get 98. So that means the angle shown here in red is going to be 98 degrees. Okay, so of course that means 7y should equal the 98 degrees. So 7y should equal 98, all right, because they are two expressions for the same angle. So of course I'm just going to divide both sides by 7 and see what I get. 14. Y equals 14. Okay, let's move on to number 22. Last problem. Oh, multiple choice. What is the value of x in the figure shown? Okay, a lot of kids have trouble with this, but it's just a matter of setting up these expressions. This 9x plus 21, that's the arc. This 5x, that's the angle. Remember how the arc and the angle should compare to each other when they are when the angle is inscribed like this. Basically, you could either say the angle is half the arc, or you could say that the arc is double the angle. To avoid fractions, I'm going to write it the second way. You know, the arc should equal 2 times the angle. That is our strategy. So I'm just going to substitute these expressions in and solve the equation. I'm going to make this a little smaller though. So the arc is 9x plus 21. So 9x plus 21 should equal double the angle. So double 5x. So understanding that was the hard part. Solving the equation is easy, but we just used the relationship that we've used over and over again throughout the last two lessons. So that's going to give us 9x plus 21 is equal to 10x. If we subtract 9x from both sides, that's going to give us 21 is equal to x. Ta-da! Here endeth the lesson. If this lesson has been helpful to you in any way, please go ahead and hit the like button for me. I would really appreciate it. And I will see you on the next video.